The text coming out of AI models has started carrying a hidden signature. You can't see it, you can't select it, and you can't strip it out with find and replace because it isn't written anywhere in the text. It's hidden in the choice of the words themselves. And since the 2nd of August, a law in Europe expects AI companies to make their output detectable, which is why this is now rolling out across the industry. So this is how it actually works, shown on a real one, running on this machine. First, what it is not. In April 2025, people started finding strange characters in ChatGPT's output. They looked exactly like normal spaces, but a code editor showed them as something else, a narrow, no-break space, one of Unicode's invisible characters. The internet decided OpenAI had started watermarking its text. Except one find and replace removed every trace of it. OpenAI said it was a quirk of training rather than a watermark, and within days, the characters were gone from the output. The em-rumor is the same shape. The models really do overuse it in words like delve, but those are habits from training shared with plenty of human writers, and anyone can edit them out in seconds. A mark you can remove that easily can't be what a law relies on. The real technique was published in 2023 by researchers at the University of Maryland, and it hides the mark in the one thing you can't strip out of text, the words themselves. Every time the model is about to write its next word, a secret key takes the previous word and splits the entire vocabulary. Every word the model knows into two random piles, a green list and a red list. The model then gets a small push toward the green pile. It's a bias, not a rule, so it can still pick any word, and the text stays normal. One word later, the key deals completely new piles, which is why no single word shows anything and why reading the text tells you nothing. But whoever holds the key can replay every split. They take the text, recompute which words counted as green at each position, and just count. Unmarked text comes out near a quarter green because each green list covers a quarter of the vocabulary. Marked text keeps landing above that, and after a paragraph of words, chant stops being a believable explanation. That implementation is open source, so we don't have to trust the paper, we can run it. Here's a small open model running on an ordinary Windows PC with a key made up for this video. Same prompt, same settings, generated twice, once plain and once with the watermark on. Both answers read like perfectly normal AI text. They even open with the same sentence before drifting apart. Now, the detector. One note first, models write in tokens, word-sized pieces, so the counts on screen are token counts. The plain text scores 26 green out of 114, right around the quarter that chance predicts, so the verdict is no watermark. The marked text has 219 tokens to score. About 55 should come out green on their own, and the detector finds 90. The odds of that happening by chance are about 2 in a billion, so the verdict is watermarked. One more, because this is where AI detectors usually embarrass themselves. We give it a paragraph of Dickens written in 1859. It scores below chance, and the verdict is clean. The detector checks for its own key, nothing else, and Dickens doesn't carry it. So if it works this well, why isn't it everywhere already? Google actually has been doing it since May 2024. Gemini's text carries their version of this idea, called SynthID, and when they tested it across 20 million real responses, users couldn't tell marked answers from plain ones. OpenAI built a watermarker too, and reporting from the Wall Street Journal says it sat finished for about a year, described internally as 99.9% effective. It never shipped, partly because a survey found almost a third of users would use ChatGPT less if it did. What changed the maths is a law. Since the 2nd of August, the EU's AI Act requires providers to make AI-generated content detectable, marked in a machine-readable way, with fines up to 15 million euros or 3% of global revenue. 9 days after that deadline, Anthropic announced that new Claude models watermark their text from launch worldwide using Google's published approach. OpenAI says provenance for text is coming, and Grok declined to sign even the voluntary code around the rule. Now the limits, because the companies shipping this are honest about them, and this video should be too. Light editing doesn't remove it. Watch what happens when we delete every 8th word of the marked text. The detector still catches it comfortably. A real rewrite is different. We ask the model to paraphrase its own marked text, every sentence rebuilt, and the score falls straight back to chance. The signal lives in the exact word choices, so replace enough of them and it's gone. It's also thin wherever the model has few choices to make, short factual answers, and especially code where Anthropic itself says the mark is nearly non-existent. A model you download and run yourself doesn't have to mark anything at all. And the part most coverage skips is that you can't check any of this. Detection needs the company's secret key. Google's checker sits behind a waitlist for journalists and researchers. Anthropic's is still a promise, and there is no public tool where you paste a text and get an answer. So here's where this lands. The watermarks are real, they're spreading because the law now asks for them, and they work in exactly one direction. The company that made a model can prove a text came from it. Nobody can prove the opposite. Unmarked text proves nothing, since plenty of models don't mark at all, and any marked text can be paraphrased clean. The question everyone actually wants answered, whether a human wrote something, stays unanswerable from the outside. What exists instead is a signature spreading quietly through AI text, put there by law, and readable only by the company that holds the key.